Welcome back. This is our physics class today, and you have a question. It is a continuation on the last episode. This is motion, linear motion. It is linear motion. Now, a car traveling at 20 meters per second is brought to rest in 10 seconds. Find the distance it travels. All travels. Now, before doing this number, you must know initial velocity, final velocity, the time, the distance, and you must know the other three equations of linear motion. The first one, let us remember, we have V equals to U plus AT. The second one, we have S is equal to UT plus a half AT squared. And the third, we have V squared is equal to U squared plus 2AS. You must remember these equations. If you are doing any linear motion number, you must know the equations of linear motion. Those are the three equations. Now, since you are going to do this number, so we must first draw a small curve. It is called a velocity time. A velocity time graph. This one, where you have the velocity this side, and where you have the time. So the time is measured in seconds, and the velocity is measured in meters per second. Meters per second. Now they are saying that a car was traveling at this speed and was brought to rest, meaning that initially the car was traveling, so this becomes our U, and brought to rest. Now finally the car was brought to zero. The V is down here. This changes. The V is not up now. The V is down because the car was brought to rest, meaning that finally the car was resting. And the V always represents the final velocity, and U represent the initial velocity. Initially the car was moving at 10 meters per second, and finally the car was brought to rest, meaning it was brought to 0 meters per second. Now the time taken in between there, it is this one, 10 seconds. So you have 10 there. So you have 20 here. We have U here, which is a 20. We have V here, which is a 0 meters per second. Don't write any limit because we have written the indication there. So write 20, the seconds there. So the car on the graph, it will be represented like that. The car on the graph will be represented like that. So the distance covered is always the area covered under the graph. This area is the distance covered by the car. So how do we find the area of a triangle? This is the first method, and very simple to get this answer. The area of a triangle is always a half times h times height times b times height times base times height. That's the area. Since it is the distance, I'm going to write s, because I told you in the last episode, s means displacement. So it will be a half. The base of this one is from here up to there, which is 10 times 10. Now the height is from here up to there, which is 20. So we are going to be having a half times 10 times 20. So these two can go with this one. So the remaining is 10 there. So it will be 1 times 10 times 10, giving you 100 meters, because distance is measured in meters. So that is our answer. If you know the approach, that the area under the graph is the distance covered by the moving particle, or any particle like a car. Let us have another method in the next episode.